So
Awesome.
we've got all the preparation done. So should we open up the quiz?
I waited too long not
Yeah.
signing out. But yeah, we'll go ahead and open it. I just gotta sign in really quick.
Okay, no problem.
All right, we're good. All right. So number 3, when taking samples of n and n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? It would be
Skewed right, right?
good, right? Yeah, it would just
Skewed
be the
right.
same.
Yep.
When taking samples of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed?
Would that
It
be
would be
normal?
normal. Yeah, because it's over like 30 or whatever.
Yeah.
The law
Okay.
of large numbers or whatever.
Mm-hmm.
Yeah.
So when taking samples of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? Also normal, right?
Yep. Yep.
Yeah.
The homework really drove that point home. Well, I guess the prep assignment.
Yeah.
Yeah.
When would the distribution of means be normally distributed? Choose all correct responses. So instead of saying first, second, third, fourth, I think we learned that they're going to be in different orders. All
No.
right,
Okay.
let's.
So let's see. Data are drawn from a population that is normally distributed and the sample size is small. That's
Yes.
correct. Mhm.
Yep.
Data are drawn from a population that is normally distributed and the sample size is large.
Okay,
That's
maybe they
correct.
are in the same order.
Yeah, I think they are.
Okay.
Data are drawn from a population that is right skewed and the sample size is small.
No.
I don't
No.
think so, no. And then data are shown from a population that is right skewed and the sample size is large.
Yes.
Yes. Yeah. Okay.
Which of the
Which is,
following gives the best explanation of the central limit theorem?
let's see.
I kind of get the law of large numbers and the central limit theorem confused.
Yeah, I do too.
It says
I would
here
have
the
to go back.
distribution of sample means is normal when x is normally distributed or when, thanks to the central limit theorem, our sample size is large. So it's got to do
Okay.
something to do with the large sample size.
I think it's if the sample size is large, the shape of the sampling distribution of the sample mean x will be approximately normal.
I think that sounds right.
The shape of the sample.
I think that sounds right.
Yeah, I think that's right.
Okay.
Let x be a random variable with population mean 10 and population standard deviation 6. Suppose a sample of size 36 is drawn from this population. What is the mean of the distribution of sample means?
What is it? Is this the one where you take the standard deviation and divide it by the square root of n, right?
Yeah, I can just grab my calculator.
So
Would it just be one?
I think so. Yeah, because the square root of 36 is 6, right? And it's just 6
Yeah.
over 6.
Wait, wait. How do you do this again? What's the proper equation?
It's omega, which is your standard deviation, 6, over the square root of n, which is 36. So square root of 36 is 6. And so you end up with 6 over 6, which is 1.
Hold on. Can I put it in my?
wait. No,
Yeah.
no. That's number 9. That's number 9.
Okay.
Right?
Yeah. What is the mean? So.
The distribution of samples.
Oh. Okay.
Yeah. So for the 8, I got 10.
So what's the where'd my pen go?
Oh, wait. No, hold on. Let's see. Oh, it's just because it says the population mean is 10. I think.
Yeah, I
think it's
is it
10.
always the same then?
Yeah,
Okay.
Yeah.
it's 10. And you're
Yeah, 'cause
right
I'm
about the
looking at
next.
the
The next one's 1.
Okay.
So. That's where
Yeah,
there's just 3 decimal places. Yeah, it's only 1.
That's 1 over
That's
1.
weird.
Well,
Just
because I
one.
think on the last homework she said from now on in this class we're going to be using things to like the 3 decimal places or whatever, right?
That's true. Yeah.
So for number 8, it's just because the mean of the distribution of the sample should be the same as the population sample, right?
Yes.
Mhm.
Regardless of the distribution of the population, if the sample size is large, what would be the shape of the distribution of the sample mean? Normal, right?
Yeah, should be normal. What theorem would justify your response to question 10? Be the central limit theorem.
So the law of large numbers states that as the sample size gets larger, the sample mean will get closer to the population mean, is what it says. So
Okay.
I think that one's going to be the central limit theorem then, right?
Yep. Yeah, that's what I put, the central limit theorem. So,
All right. Should we press
Okay.
submit? I hate
Let's
this
see.
part.
I
I
do
know.
too, in case I missed something.
Yay! Look at that.
Okay. This is relatively easy. I just have to find out a way to remember which one's the central limit and which one's the law of large numbers.
Yeah, I had to go over those a couple times. I still need to probably a couple more times. So.
It just makes more sense to me that the other one would be called the law of large numbers. So that's
True.
why I get it
That's true.
every time.
Yeah,
That is true.
that's very true. So.
But hey, at least it was short. Not that I don't enjoy you guys' company, but I got plenty of other things to do.
No, it's nice.
No, I agree. I have so much to do, so that's probably best. And does anyone else have any questions or anything? I think I'm
No.
good. So
I don't think so. So
Cool.
awesome.
Same time
All right.
Thursday?
Yeah, we'll
Yeah,
plan on.
for
I mean,
sure.
we'll plan on 3:30 and whatnot. So.
Cool.
okay.
All right, see you guys
All
then.
right. See
Thank
you
you
then.
guys.
Bye.
See ya.